Hi, my name's Elizabeth, and this is my attack reproduction presentation, and I chose malicious code in websites. SQL injections use SQL queries as web page input with the intention of unauthorized execution of the database. And in December of 1998, a security researcher, Jeff Forrestal, discovered SQL injections and disclosed it in his magazine Frag 54. And it can result in a variety of things, including unauthorized database manipulation and system takeover. And I implemented the SQL injection in my login page. The cross-site scripting is when attackers execute malicious scripts in a trusted, vulnerable website, and it was discovered and disclosed by Microsoft security engineers in late 1999. And it can result in a couple things involving crashing a browser and compromising a user's account and data. And I implemented this through my networking website's posting feature. Cross-site request forgery is when attackers trick victims into performing actions they don't intend to on a trusted website, and it was defined and disclosed by Peter Watkins in 2001. This attack can cause a couple things, including compromising a website, gaining heightened privileges, and manipulating and stealing data, and I implemented this through tricking users into changing the admin password. So, executed by Sammy Kamkar in 2005, this worm allowed anyone who viewed Sammy's profile to add him as a friend, and then it also injected the viewer's profile with the malicious script so that anyone who viewed their profile would also gain Sammy as a friend. And I implemented the Sammy worm through the Add Friend feature in my application. And the main technical challenge of this was overcoming the built-in defenses that browsers have against executing script tags. So here we'll demonstrate a SQL injection. So first we can log in like normal, as you can see, with the given username and password. However, if we're a malicious user and we don't have the password, we can also do this, which is admin with a single quote, space, hyphen, hyphen, space. And this, as you can see, we can log in with. And then we can also do admin single quote, as you can see here, the logical OR, and then 1 equals 1, but without the single quote at the end. And as you can see, we can log in without any password. And this is because this SQL statement is intentionally for this project vulnerable, since we directly inject the username and password into the SQL query, and this makes the queries this and this. So as you can see here from that first one, this is a SQL comment, so it'll comment out everything after this. So this makes the query essentially just checking for admin, bypassing password verification. And similarly here, this has a logical OR and has a higher precedence than OR in SQL. So this will make, this is always true and false, so that'll be false. However, this is true. So true or false equals true, and it'll pass without any password verification. And thus we can gain heightened privileges into the admin account using SQL injection. So here we're going to show an example of a cross-site scripting attack, specifically a stored cross-site scripting attack. So here we are logged into the message board as Liz, and we can post as normal, just text like hello. However, this is vulnerable to a cross-site scripting attack. And if we were to post the code to a button with a malicious alert, we can do that here and it would render, and anyone who logs in and clicks this will then be attacked by an alert. So this is vulnerable because, as you can see here, when we grab the post content, and the content is not sanitized at all, it is grabbed as is, sent to the back end, where the back end stores it as is. And so when we render it directly as it was written as inner HTML, which then makes it executable. So this shows a vulnerable site to a stored cross-site scripting attack. So now I'm going to demonstrate cross-site request forgery. So first I'll show how my change password feature works. So we're going to change Liz's password to secure456. Perfect, now that password is changed, and as you can see here, I'm using a GET request for my change password, and that URL is displayed up in the address bar. And this is what makes this vulnerable, because an attacker could take advantage of this and take this structure and put it into a simple HTML page with an image, and the source is that GET request URL. And they can change the admin password to a different password, which is password hacked in this case. And as you can see here, originally, we have our admin password as password123. So let's trick someone into changing this admin password unintentionally. So we're going to go back to home, and for example, someone can post something like this. And this is going to be a phishing link that once someone clicks this button, they will run this page, and which is this page. So once this page is run, this GET request will be sent to the server and the password will be changed for admin. Let's go back, post this. Okay, cool. So let's have Liz click to view this. Okay, and then this takes us back out. And then let's reload this. Users. And as you can see, the admin password has been changed by Liz just clicking on the button. So now if we're the admin and we want to go into our account, let's try password 123, our original password, and that fails. And that is because it has been hacked. So let's go password hacked, and we can get in. So now we're the malicious user with admin access, which is the privilege to delete posts. So now let's demonstrate the SAMI worm attack. So how this is going to work is that this profile worm has this malicious script in its bio, and then anyone who views that bio will automatically add worm as a friend and then inject this script into their own bio, such that when anyone views their profile now, will also automatically add worm as a friend, and then this script will continue propagating as such. So let's demonstrate this. So now we're at the profile admin, and let's just add a friend like normal. So we want to be friends with Liz. Add the friend added successfully. Now admin is friends with Liz, and Liz is friends with admin. So that's great. So now we go to the worm profile, and we see here we're not clicking add friend, but then we refresh and we can see that worm is now friends with admin and admin is friends with worm. And so let's go to the table. As you can see here, admin's bio now has a malicious script, and it's been injected with this malicious payload that will automatically add worm as a friend to anyone who views admin's profile. So let's test that out. Let's log in as Liz. And view profile. So now this is our profile and we're friends with admin only. Let's go to our friend's profile and we refresh. And as you can see, we go back to Liz. Liz is now friends with Worm, even though we never viewed Worm's profile. And that's because we viewed admin's profile, which had this malicious script. And now let's go back and reload users. And as we can see here, Liz now also has that malicious script in its bio. So here we implemented defenses against SQL injection. We used parameterized queries for the username and password instead of injecting them straight into the SQL query. So let's try some of the old SQL injections that used to work. And as you can see, it fails. Let's try another one. And it also fails. So here we're going to defend against a cross-site scripting attack. So here, as you can see, now the button does not render and we cannot execute the XSS attack alert. And that's because instead of posting the element with inner HTML, I instead use text context. So it won't render the script, but it will actually just post it as text. As you can see here, this is where that happens. So as you see, the button is just posted as plain text. Now we're going to defend against cross-site request forgery. And here we're going to use a post request to change the password instead of a GET request to do that. So here, let's see. So now we change the admin password and no URL pops up at the top. And as you can see here, the admin password is password 123. So now before, when we ran this page with that malicious GET request, it could change the admin password. So let's try that again. And like before, it does log us out. So let's try admin and then let's do password 123. And it still logs us in because we can see here that password is not changed. So this cross-site request forgery does not work anymore. So now we're going to defend against the SAMI worm attack. So before, this code was able to propagate and infect other profiles because its ability to execute in the bio. However, now in the user bio, we can read it in as inner text, and therefore the script will not be executable. So as you can see here, we're logged into Liz, and now we can go to Worm, and we can see that the script is just plain text. Before, when Liz would view the profile Worm, it would automatically add Liz as a friend. However, we can see here that does not happen, and the script does not get injected into Liz's bio. Therefore, we have defended against the SAMI worm. Some of the main lessons about security that these attacks show us are the importance of validating and sanitizing user input in web applications, how JavaScript can be exploited in web applications, and the ethical responsibility that website owners have to secure user data. The attacks in this presentation all have implemented defenses, but are still at large today. So a lot of the research on increasing detection and defenses against these attacks involve automation using AI and ML to analyze and detect these vulnerabilities. Thank you for listening to my presentation, and I hope you enjoyed it.